This problem has to do with compound interest and doubling times, the doubling amount of time it takes to double your investment. And we've got this formula right here. I'm going to write that down here. It's A equals A naught e to the RT. And here's what all these letters stand for. This A is the amount of money you have after T number of years from now at this interest rate, and you start with this much. So if you start with this much, right, that's always our start value. You start with this much, you invest it at a certain interest rate, leave it in for a certain time. That's the amount of money you have after that time. Now what we're looking for here is doubling time. So doubling time, all right, now doubling time means if you start with A naught dollars, right, you start there, you want to double it, so you would have 2 times that number of dollars. So what we're looking for is we want the amount of money that we have to be twice the amount of money that we started with. So let's start here in problem A. That's going to be at 6%. So at A, we're going to have, I'll write the formula. A equals A naught e to the 0.06 t, right? 6% is 0.06. Now we want A to double. We want A to be double A naught. So we're going to have 2 A naught equals A naught e to the 0.06 t. I'm going to cancel these A's, right? I'm going to divide both sides by A naught, so those will divide out. And I get 2 is equal to e to the 0.06 t. Take natural logs. Natural log of 2 is equal to 0.06 t, right? I'll just remind us, this is the natural log of e to the 0.06 t, which is just that number, right? The natural log and e undo each other. So I'll divide, so I'll get ln2 divided by 0.06, that's equal to t. And we're asked to round this to 3 decimal places, so I'm getting 11.552 years. So that means if you start with some amount of money, any amount of money, in about 11.5 years, you will have double that amount of money if you invested at 6%. Now in part B, we're going to invest this at 8%, so we would expect this to be a shorter doubling time. So we're going to have, I'm just going to start it here, 2A naught equals A naught e to the 0.08 t, right, at 8%. This is at our 8% rate. So again, we will divide out the A naught, so that's nice because that means we're just left with this equation, which is 2 equals e to the 0.08 t. And you'll notice that there's no A sub 0 in here. There's no starting value. So it doesn't, the time does not depend on the starting value at all. Start with any amount you like. All right, now let's take natural logs of each side. So we'll get ln2 equals 0.08 t. So we'll divide. So we'll get ln2 divided by 0.08. Now look, that looks very much like this one, right? At 6%, we had ln2 over 0.06. Now we're at 8%, we got ln2 over 0.8. All right, that's equal to t. Now, when I did that, rounding to 3 decimal places, I got 8.664 years. So if you're at 6%, it takes 11.5 years to double your money. If you're at 8%, it takes a little over 8.5 years. Now at 10%, let's see what happens. So in part C, we're going to be at 10%, but I know what's going to happen here, right? T is going to be what? ln2 over 0.10. So what do I get here? When I round to 3 decimal places, I got 6.931, or essentially 7 years. So I get 6.931 years before I double my money.